So you remember that the area formula, I keep harping at that it's important. That the area is 1/2 AB sine gamma. At this point, I think you understand that it's quite important, even if it's just useful. For example, you remember it was quite a little trip to find the area of the equilateral triangle with, say, sides 5. We would have to split it in half and then find the height with the Pythagorean theorem. And it takes a little work, but if you use this formula, it's 1/2 5 times 5 times sine 60. It's a one-liner. You can almost do it in your head, right? So even when it's not earth-shatteringly important, it's quite useful. But there is a place where it's just so nice. So let's say we have a triangle that is superscribed. All right. Now let's say that this angle here is alpha. Then you know this whole sine alpha equals a over 2 divided by r is coming from the fact that this is twice alpha, right? And then we take it apart, and then the Pythagorean theorem. And I mean, this statement is just a trigonometric statement. It is a over 2, and here is r, and sine alpha is a over 2 divided by r, right? So this should be familiar. But now I just want to stop short at, if this is alpha, this is 2 alpha, because it's inscribed and central angle belonging to the same arc, namely this arc. Similarly, if this angle is beta, then beta is an inscribed angle belonging to this arc, which is 2 beta there. And then this is, if this is gamma, this is 2 gamma. And yeah, if alpha plus beta plus gamma is 180, then twice them should add up to 360. So it looks weird, but it's not weird. And now for the area of this triangle, check this out, is 1/2 r squared sine 2 alpha. It's just that formula, 1/2 r times sine of 2 alpha plus 1/2 r squared sine of 2 beta plus 1/2 r squared sine of 2 gamma. And then we can factor out r squared over 2, I guess. And it's sine of 2 alpha plus sine of 2 beta plus sine of 2 gamma. Oh, cute little formula that I think it's a lovely formula for the area. It kind of, yeah, that's it. This is what I wanted to show you. Well, it kind of reminds me of when you have the inscribed circle. I said inscribed. And then we split the triangle into 3 triangles with the same height now, right? If this is A and this is R, then it's 1/2 A times R is the area of this triangle plus 1/2 B times R plus 1/2 C times R, and that's the area. So the area is 1/2 times the perimeter times R, because if we factor out R and half, we get A plus B plus C. So it kind of reminds me of, there is some similarity here. We're looking at the area as a sum of 3 triangles, and we're exploiting the fact that the radius is the same all over the place. One with the, yeah, I think these are both once you get over this formula, then these are both pretty intuitive. Also, it just occurred to me, and I wanted to show you, is what happens if the triangle is obtuse? If the triangle is obtuse, then the center is outside of the triangle. So then this sum maybe doesn't work. So there is a little worry that this formula that we just derived, maybe it breaks down with obtuse triangles. So, you know, if the triangle is right, then the center of the superscribed circle is on the triangle. And if the angle is bigger than 90, then it's outside of the triangle. Basically, if you want to understand it, start with the circle and then draw a triangle in there that's not there. All right, and let's say this is alpha, let's say this is beta. Beta is the big one, and this is gamma. I always go by the arc. So here is this arc. Does it belong with alpha, with beta, or with gamma, this arc?
Gamma?
Yes, it is. And then the same arc, the central angle is twice gamma. It's kind of weird at first. And then we're going to look at this arc. That seems to go with alpha. And so to the same arc, the central angle is 2 alpha. And then beta is weird. I mean, 2 beta is weird. If beta is bigger than 90, then 2 beta is bigger than 180. This here is 2 beta. Again, if the 3 angles add up to 180, then twice them should add up to 360. So that here is 2 beta. So here is what I thought at first. So let's say we have 1/2 r squared sine of 2 gamma. That would be this area here. And plus 1/2 r squared sine of 2 alpha would be this area here. But that's too much. We would have to subtract this one. But so we would have to subtract 1/2 r squared sine of, well, either 2 gamma plus 2 alpha or 360 minus 2 beta, right? That would be subtracting this extra. But then we can simplify this. Sine of 360 minus beta is minus 2 beta is the same as sine of minus 2 beta because they're coterminal. And that's the same as minus sine of 2 beta. And so if we simplify it, we get the same formula back. This minus will become a plus, and this will just become 2 beta. So we get back this formula. This formula still works. Right? If I say, so I'm just going to repeat this to 1/2 r squared sine of 2 gamma plus 1/2 r squared sine of 2 alpha. And then minus 1/2 r squared times minus sine 2 beta. And there it is. So the formula still works. I found that lovely.